is G. Truglia and
Wayne Colonna.
we have something special for you tonight. It's Driveability meets Transability. So, sorry about the little late start, about 5 minutes late. We have a bunch of people here tonight I'd like to acknowledge. Doreen behind the camera, Pierre not only behind the controls, but helping us on the car. Alex Fortillo, that's my buddy over there, helping us out with a lot of good things, hooking up, and Eric Gibney here in the background. So we have a lot in store for you tonight, and we're going to get going like this. So we'll move the slides ahead. We're going to be talking about what's covered, right, Wayne?
Yeah, we're going to be talking about fast checks for shift and TCC solenoids and the 3 pressure control solenoids that this particular transmission has.
And let me stop you there. You know, when Wayne has this up there, TSBs, you know, I can't tell you this enough. TSBs are something very, very important to read. So make sure you always check into them. I also want to make sure you've seen Wayne's article in Motor Age on this, because this is just like the live car you had down in Florida.
That's right, that's right. It would be the March or April issue of Motor Age.
Very good. And other stuff we're doing, Wayne?
Well, we're going to mention the transmission range sensor, and most importantly that this has 3 speed sensors, and turbine shaft speed sensor, input shaft speed sensor, output shaft speed sensor, and all 3 sensors share the same ground wire with the heated O2 sensors.
Oh, so come on, Wayne, you're telling me an O2 sensor? That's going to cause some sort of a problem with these transmission things? That's drivability, guys, come on. We're not going to screw you over, are we?
Your drivability is going to hurt my transability.
So basically, guys, no joking around, a oxygen sensor, especially when it's on the same ground, it could cause a problem with transmissions. In fact, today, tell them what happened today on the Dodge that you're working on with the transmission.
Well, we actually had a Dodge with a 42RE in the shop, and it had codes for the governor solenoid, and asking some questions, we found out that it also had an O2 sensor, and that particular vehicle, the JTEC module, is a multiplex, and it shares the driver, and as it was switching drivers because of the O2 sensor, the shared driver with the governor solenoid, it was given those codes when really it was the O2 sensor.
So it threw a lot of codes like voltage high, voltage low,
and it had a drift.
And Alex, who was working on this thing, he's seen that code, and we just happen to have the master of disaster over here, the guy who knows everything about transmissions, Mr. Transmission himself. Well, guess what? This was a wind up being an easy fix. It has to do with an oxygen sensor. So don't forget, sometimes looking at the grounds and know how grounds are on car. G1 is always the front, 2, 3, and so on, getting back to the back of the car near a G4. Other stuff that we're going to check.
Well, actually, we're going to be talking about different things that can cause the transmission to have downshift clunks, bumps, harsh shift, hesitations, and many times because of transmission codes, engine codes, ABS codes, we sometimes think of them as separate and not interrelated, and how they are all interrelated, and that they can give us all kinds of transmission issues. So we're going to touch on that a little bit.
So that's always good. In other words, what you're saying here, not always to interrupt you, but I have to do that anyway.
Okay.
At any rate, you should always do a health check to check everything. Sometimes even an airbag code. I know Alex just had another one of these recently.
Well, that just happened yesterday with the Volvo.
With
right?
the Volvo.
Right. They couldn't reset the adapts, and I asked if there was any other codes in the system, and it turned out that there was something with the ABS.
ABS.
And once they got
that was the airbag.
Airbag, right.
So think about that. Whatever tool you're using, you need to scan. Tonight we'll be using the IDS and the Genesis Touch. We know most of you don't have the factory tool, but we want to show you on an aftermarket tool that if you go through and look at everything, we're not going to show you how to do a health check. You should know how to do that on your scan tool. That's for a different day. But we want to cover a lot of transmission stuff tonight and drivability. So this affects this. So if we have a problem, he has a problem. If he has a problem, we have a problem. Continue on.
Well, and we're going to be mentioning mass airflow sensor, TPS. One of the things that can happen with this particular transmission, wrong overdrive planetary gear sets can cause the transmission to have different shift complaint. Then we're going to talk about a couple of things related to flashing the computer.
Yeah, now flashes, there's a big thing, and I put some of this information in here tonight on this presentation, but we're going to be also on this car. And by the way, if you can just show them where we have the Ford here, and when we're on this car, we're basically going to be looking at some real problems, okay? So, that being said, let's look at some of the TSBs. And thanks to AllData on this one, TSB 09-2215. There are other places you can find it, but this is where I got that, so I'd like to give them credit. Here's a problem on this vehicle that Wayne had in his article. It was water basically leaking down from the drip tube, the AC system, going in and causing havoc. And we're going to show you wreaking havoc. And then we're going to test what you found wrong. But right now we just want to give them some information. Okay?
If I could just add to it,
Please.
when you read the article, at that time that I wrote the article, I wasn't aware of this TSB. And I mentioned about redirecting the flow of water so that it wouldn't drip down in the area of the solenoid connector, which was the problem, a very common problem. And now I find out with the TSB, they actually have a weatherproof seal that goes around it, and that's what this TSB is about.
Exactly, that's what it shows. Okay, so let's look at another TSB. Here's one, loss of memory only on the 6-speed.
Yeah, I just wanted to bring this up. This particular vehicle can have a 6-speed transmission in it. So I just wanted to bring that up. We're working on a 5-speed, but there are many different reflash fixes for the Explorer with the 6-speed. So keep that in mind. Make sure you know that we're looking at either a 5-speed or a 6-speed transmission, and there's plenty of reflashes available with some issues with the 6-speed.
Excellent.
The 6R60 is what they call it.
TCC cycling, torque converter clutch cycling insurgent.
Yeah, would be one of the ones that we would see with the 6-speed.
It exhibits a bump and feeling when braking to a stop or less than 10 miles an hour.
Right.
It says to fix the bump while braking to a stop, delayed action procedure is basically reprogram the transmission. And that is important.
Yeah, and that's why it's always good to check first, if you can, what type of reflashes are out there for both the 5-speed and the 6-speed, because you may get over on a problem before really spending a whole lot of time on anything else.
Right, so they should identify the transmission. And I know we have that little book, but you have an app on your phone. Your phone,
Right.
oh, there it goes.
Yeah, this is a great chart to have by Corteco, Transtech, and it helps you to identify the transmissions that you have. It's also an app. So if you went to the website, you could actually download this app if you have a smartphone, both Android or Apple. Great to have.
It really is. Comes in handy when you're looking at what transmission is really in that vehicle. Now, some of the stuff that we're going to be on tonight is some of these solenoids, right?
Well, yeah. Now, originally when I worked with this particular vehicle in the shop in Miami, I thought it was great to write an article on it, because what we're going to show you tonight, the various different ways we can check these solenoids, can actually be employed on many other vehicles. It's just not this, but we wanted to show you this as an example, because there are many configurations where the solenoid pack has got one power feed that goes into it, and then the solenoids are being controlled on the ground side at the PCM. So there's a variety of different ways that we can do checks. Now what makes this particular vehicle nice is everything is out under the hood, easy and accessible, so we can go through the testing pretty quickly. And this could be the same with even Dodge and Chrysler vehicles, so it's good to understand the whole concept, where then you can employ that on different vehicles. So.
And we didn't just bring Wayne up here to just show you slides and stuff. So what we're going to do is move this box in here, Wayne. And because it's not as easy to move in as we practice. And we're going to talk about what is actually on this car here. And Wayne, why don't you explain a bit before we get into some testing?
Okay. There's quite a bit of things I'd like to talk about here before we actually get into this vehicle. And I know that we just finished explaining that you can employ the principle of checking the solenoids on a variety of different vehicles. But what is unique to this particular transmission is there's 3 versions, a 5R55N, 5R55S, and a 5R55W. It has to do with ratios and things like that, different car applications. But they all have this kind of a solenoid assembly. Now what's unique about this solenoid assembly, first of all, it's all one assembly. So if you got a solenoid that's bad, you have to change the whole thing.
One integrated type of...
Right, exactly. Now, you have, what's unique about this transmission is you've got 3 pressure control solenoids. Pressure control solenoid A, B, and C. These are 200 hertz solenoids. They duty cycle between 14 and 38%, and usually on amps it runs between 0.2 amps to 0.9 amps. And the 0.9 amps is low pressure, 0.2 amps is high pressure. But now, you have these 3 solenoids, but there's 2 pressure taps. One pressure tap checks 2 solenoids, pressure control solenoid A and B. The other pressure tap just checks pressure control solenoid C. Now,
You've pulled one apart for us.
well, actually, I first want to explain what's going on here. This is the pressure regulator valve, and this is another one of the articles that you'll find in Motor Age. Okay, now pressure control solenoid A is going to work on one, actually I got this back, let me straighten this out.
So bear with us while he straightens it out so you can see how this valve actually works.
Just get that.
Yeah, of course, that's why we have extra hands here.
Okay. Now, okay, so pressure control solenoid A is going to work on this side of the PR valve to raise line pressure. Pressure control solenoid B is going to work on a different area of the valve. And then we have another area where we boost line pressure from the manual valve, okay? So now this pressure regulator valve is going to regulate line pressure based on pressure control solenoid A and B going back and forth. Now A and B are going to change line pressure, but at the same time they each also act as servo apply rate solenoids as well. So pressure control solenoid A will control the intermediate band apply rate. Pressure control solenoid B controls the overdrive band apply rate, while both of these are also controlling line pressure. So they work together in doing this. Now pressure control solenoid C controls direct clutch apply, which is for reverse and for 4th gear. But pressure control solenoid C is dependent on what's happening with B. So,
and we're going to show them that in a little bit.
right, we're going to show them that you're going to see amperage and you're going to see how they interact with each other and how they change. The point being is that when we have a problem with these solenoids, we can have harsh shift, soft shifts, delayed engagements, skip shifts, no shifts, just a whole variety of different problems. Now, to make things more interesting, is in the pump, there is this valve. Now, most solenoids have in a valve body a regulating valve that regulates how much pressure is being supplied to these solenoids. Not so with these pressure control solenoids. These pressure control solenoids are not fed with regulated pressure.
It's full.
It gets full pressure of whatever it is. So this means that if suddenly we go to max pressure because of fail-safe conditions, the high pressure could actually overcome the solenoids, and that will allow too much pressure to get to the PR valve. In reverse, we could go over 500 pounds of pressure, and it actually blows the servos apart, breaks them in pieces.
Then you really have to shoot
Oh yeah,
the
yeah,
button.
you totally got issues. Now this valve here is a pump flow control valve. This controls the pump flow to the entire transmission. And if this goes bad, then it also starves the whole transmission of the right amount of pump volume. And so now you can have a variety of different issues that seem to be a bad solenoid pack.
So basically what you're saying, and we're going to ask for questions in a couple of minutes here. Basically you're saying this here could be bad, and it looks like
Exactly,
that.
exactly.
So this is very important, and is
And the
no
unfortunate
real way.
Right, there's, it's inside the pump.
And there's no real way of checking it unless you do a bunch.
Now, just a couple more things before we move on.
Let's see if he has questions. Pierre, any questions? Or?
Actually, one question was, can you please give us the website on that book, on the book, the identifier book, and he wanted to know if it covered all transmissions or just Ford.
In fact, it covers all transmissions around the world entirely. And you go to transtech.com, and Transtech is TRANSTEC, transtech.com.
And any other questions, Pierre?
That was it.
Okay.
Okay, now a couple of other things here is the way this solenoid pack is designed. When it comes to you brand new or been sitting on a shelf for a while, so I took one of these apart, which once you do that, it's
done.
It's done. You have to break it to take it apart. But I wanted to show you the solenoid. And the solenoid has 3 O-rings on it, so these O-rings can fail and you can have issue. But what happens is when the valve body, or the solenoid body sits for too long, the oil drains out of the valve. There's a valve at the end of this that is moved to regulate that pressure. That's right. It gets dry, and when you put this in, the valve can actually seize in the solenoid. So when you get a new solenoid block, you will want to soak this in oil, and in fact, you could go on the back side and tickle the solenoid to make the valve jump around so you can get it lubricated before you
Now, explain this tickling. Your transmission guys, I don't know.
Well, actually, Pierre was the one that gave me that terminology. Power and ground, but you hit it with ground or power quickly. You know, you're just tapping it.
So we can use our power probes.
You could use a power probe.
Alex, can you get the piece for this? The ground wire? It's in the bag in there.
While they're doing that too, there was an issue earlier, pre-2005, that Mercon 5 fluid would actually cause solder corrosion. And there was an additive called XL11 to help update that. But those days are kind of gone.
Was there a TSP in it?
But, pardon me?
Was there a TSP in it?
Yeah, it's an old TSP.
Question was, in case you couldn't hear it out there, is the TSB on that? And yes.
I did have a couple of questions, actually. Would the valve in the pump
It's in the bag.
cause a B solenoid code?
Actually, this valve in the pump could definitely cause performance codes across the board because it starves the entire transmission. And the oil that goes to these pressure control solenoids comes from this flow control valve. So you could starve these solenoids of enough flow where it can't function properly.
Would you say if you lost the pressure at your tap point, that could be a cause of the issue?
Exactly.
There's no flow, no pressure, right?
But the question was, if you check the pressure at the taps, your main line pressure for pressure control solenoid A and B, and pressure control solenoid C, if all pressures are low across the board, it can be due to a loss of flow, pump flow. And this also can cause overheating conditions as well.
So we could take the solenoid, these are the pins that are in the back of here.
Right.
We could take this, and this is the power probe hook is why one of the reasons we just got this in, and we were a little later in starting, we wanted to show you this. With this tool, we could basically see, you know, what the resistance is, and I don't know if they can get in there. You know, it says ohms 1K. Can you grab that?
When she's zooming, it zooms a little slow, but she's getting there.
That's what it says.
There you go.
Well, there's,
There you go.
that can't be 1 page.
4.69 ohms.
That's right, now we got it.
That must have been hitting something.
That was the scale.
That was okay. And now we can look at, there is amperage and there's the ohms. 5.17 ohms, 2.6.
That's
Yes.
right, now that's right. Exactly.
And you could actually hear this. We'll put it near Wayne's mic. Oh, come on, we love when you lean in. Look what I can get him to do. This is a transmission guy.
Now, what's that got to do with anything?
I figure, we have to get you in the club.
Get your shift
That's how you
together.
tickle the sensor, or tickle the solenoid.
Talk about tickling, I don't know about that.
All right.
So we could do this even on the back of this valve body right here. Go in, these are the pins that we were on before, same setup, and basically, once I'm on here, it shows me battery voltage, there's my ohms, and when I hold it down, 5.11 ohms, 2.6 something amps. Don't hold it on real long. You know, you should be, again, soaking this like you said,
Right, soaking it.
cycling it,
Right.
and that'll be good.
And you see, when you're looking at this side, see this solenoid pack has
The screen.
a screen that goes over it, and then
And
it
a
has
plate
the
and a
the
screen.
plate. And you can just, it snaps in, you can pop it off, you take it out, and this is where the feed is, closest to the solenoids, and this is where the oil comes out of the solenoid to supply pressure at its respective circuit.
But it's not recommended that anyone takes this apart.
Oh, no, you could take this.
You could take the front of it.
This you can. And you can make sure you get oil in here and make sure oil's coming out of here, because the way these solenoids are configured is when they're off, they're at max pressure. So as you put oil in here, oil should come out of here and you should see a flow. But that's when you can work the valve and make sure the valve itself is lubricated in the bore.
Two questions.
Yeah.
One, should you do that in the oil on a new solenoid pack, or to get all the oil distributed so it won't seize?
Absolutely, because that's what I was saying before. Sometimes these brand new solenoid packs have been delivered to you where they've been laying horizontally and it drains and it gets dry and you don't know how long it's been there, or sitting on your shelf.
Look for stains in the box, on the paper, and the wrapper.
The thing is, before you put a brand new set of solenoids in like this, lubricate the valves, absolutely lubricate them.
The other question was, back to the pump valve, would it also give gear ratio codes?
Absolutely. Yes, sir.
Anything like that? Lots of codes,
Absolutely.
right?
Yes.
Lots of,
Okay.
very good question.
Yes.
And one of the things we should say is this connector right here that I have up behind you, Wayne has taken this picture, one of them that were in the article, where he has the number of the pins actually numbered out, where we can actually do checks right here from the pins. By using the appropriate type of end in here, we can actually check with a device like this Power Pro Cook or whatever.
You do enough of them, get a pigtail.
What,
Yeah, if you do enough, Eric brings a good point up, because you guys probably couldn't hear that. If you do enough, get a pigtail, because if you have the wire in pigtail, it's nice and easy. And again, this is the same problem we discussed earlier. This is where water goes down. So they do have that boot.
with the question was, with the issue with solder corrosion, would you use Mercon SP and avoid using the additive with the Mercon 5?
Yeah, absolutely. But yeah, you can do the later oil,
So
absolutely.
Mercon
Yeah.
SP would
Yeah,
be better to
yeah,
use for the
absolutely.
solder problem.
Yeah. Oh, yeah.
Very good.
Absolutely, yes.
Any other questions, Barry?
No, I think that's it for now.
Okay, so
Okay, so these were some of the unique things for this particular transmission. And again, this is the same with 5R55 and S or W. It does not matter. Now, one of the things that we mentioned was pressure control solenoids, all three of them. The amps run from 0.2 amps, max pressure, to around 0.9 amps, low pressure, and they interact one with another. And so what we're going to show you shortly is actually seeing these we amp clamped each one of these pressure control solenoids, just so you can see it. But if we can get, oh, you have this here already.
So we put this up because this is important. Low amps equals high pressure, and high amps equals low pressure. So we're going to be using the ATS scope in a bit, and we have 3 amp clamps on there because there's 3 solenoids,
Right.
to actually show what's going on. And we're actually going to have Eric or someone put this in the air, we're going to drive it, and see what happens in different ranges.
Yeah,
correct?
absolutely.
We're also going to look at scan data to show you what a factory tool would show you and/or what an aftermarket tool would show you.
And once we get past all this, then, can we go back to the wiring diagram? Sure.
Things?
Once we get past all this, we're actually going to do checks on showing power coming to the computer to make sure that each one of these solenoid ground wires have the power going to them to verify power in. And again, this is the same idea with many other transmissions. So once we get to that stage, remember that we can employ these same principles with other vehicles.
So on this transmission, we have fuse 38 like you had in your article.
That's right.
That's our main power, and the computer is toggling ground
To control the
to
solenoid.
control the solenoid.
Absolutely.
But that's not true of every computer, correct?
No, but a lot of the, you
The
know.
newer computer controllers.
Yeah.
Very good. Very good. Any other questions, Pierre, before?
There
we-
was a question, are all the solenoids the same resistance?
No, good question.
Ah.
Pressure control solenoids A, B, and C are running approximately 6 ohms. And the shift solenoids are like 25 ohms around there, 25.
Why don't you flip one over, Wayne, and we can show them with the resistor. Okay, so let's do the first one. A is 24.8. There's our first one there. Our second one is 24.8, 24.9. Our next one is 24.7. This one, so these are going to be 24.9. They're going to be in the same amperage range,
Right.
which we've seen.
Right. So you're going to have what, about 0.75 amps or something
Yeah,
like that?
700 something,
Right,
100.
right. On these, right. You're going to have different amps on the lockup solenoid,
On the
and you're going to
lockups.
have about 2 amps on each of the pressure control solenoids.
Right. So this one is 10 points. That's quite a bit difference.
Yeah.
Quite a bit difference. Yeah. So it's something good to check. You could do your own meter. You can use something like this hook that shows you resistance, amperage, and current. That's pretty neat.
We do have a book on this that gives you all the pinouts and the details of the resistances of the solenoid. So we do have it for the 5R55 S and W, and a separate book for the 5R55N.
So it's really, they have some real good stuff there. Let's move this out of the way. You want anything you want to cover?
No, this was.
So I will take this out of the way. Going to be the OTC scan tool. This is the new Genesis Touch. And what we have up here is some PIDs we picked already. And these PIDs that we picked basically is telling us there's an amp, there's another amp, but if we start it up, let's see what happens.
Yeah, and obviously these PSI values are calculated PSI values based on the amperage control of the solenoid. So there's really no way that it can actually check if those PSIs are that PSI. What we're doing is at the PCM, we've got pressure control solenoid A. So we're on terminal 11 at the PCM. We have pressure control solenoid B at terminal 23. And we're at pressure control solenoid C at terminal 34. So we amp clamp each of these wires to get that amperage reading. And so what we're actually trying to do is observe what the computer is commanding. Now, in one of the articles that I wrote with the 5R55S in the Lincoln is a problem when we had harsh engagements into gear. There was some computers that gave us some issues. And we were supposed to see something like 0.7 to 0.9 amps when we go into gear on these pressure control solenoids. Yet, when we had a bad computer, we would see only 0.2 amps. So we were at too high a line as a result of the amps being so low. So in the article, I kind of explain that, and it's a way to be able to check what kind of amperages the computer is pulling on those solenoids based obviously on duty cycle. And of course, you got to keep in mind, we have to make sure there's no codes as well, because if we have any codes, we're going to have failure mode effect management. We could have a raising of line pressure as a result of that. But we go through this in this article, and it's either in March or April of Motor Age, and explain how to check it. And we want to see 0.7 to 0.9 amps at idle when we go into gear. And what we're going to do afterwards, once we get through this, what we're going to do is we're going to unplug the connector here. Well, we're going to show you a picture of all this as we have it amp clamped, but then we're going to unplug this. And with the key on, we should see battery voltage on each one of these wires. So that'll help us see if we've got good power being supplied to the solenoid pack. So we'll be able to look and see if we've got voltage here. And then we could actually, while it's unplugged, key on, knowing that we got power there, we can take our meter lead, switch it over to amps, and we can actually go in series with the connector to ground and check the amps of each one of the solenoids. So we're actually checking the entire circuit by checking amps right here, and just doing it real quick. These are real fast, obviously, solenoid checks by checking to make sure volts are here and that we have amps. We could, if we wanted to check resistance, turn everything off, unplug the fuse, and put a ground wire here or a power side of the positive lead of your meter, and then with your negative meter lead, just touch each one of these pins, and we can do a complete resistance check of the entire circuit. And again, these kind of checks is the kind of checks that you can do even with like the 604, the 41 TEs, and in the Chrysler and Dodge vehicles, but there the power supply is through the relay. So we just find the relay leg that supplies power to the solenoid pack, and we can actually do the same checks in this fashion.
So wait, through this main connector fuse, we could actually see all the amperage.
Right, if you clamp it on here and you know what solenoids are on, you can get a totality of the amps for a particular gear.
Just as a quick check.
Right, a quick check.
So that's something you can do there. Connected to the solenoids,
That's right.
to check current, and we have our lab scope on this. So we're going to take a close look. You're going to tell us where we're at on this.
Get hooked up to each of the 3 pressure control solenoids. Pressure control solenoid A, B, and C, because pretty much all we want to do is just see how they interact one with another. What we have over here is pressure control solenoid A, which is the bottom amp clamp. That is on channel 1, and it'll be a yellow wire. Then we're on pressure control solenoid B with the middle clamp. That is obviously going to be channel 2. It's going to be the red wire. And then we have pressure control solenoid C, which is going to be channel 3, and it'll be a green wire. Now, just so that you know, we're going to see in park, we're going to see 1 amp on pressure control solenoid A. We're going to see a half an amp on pressure control solenoid B, and we're going to see 1 amp in pressure control solenoid C. Now, this is in preparation for a park to drive engagement. Now, typically, when we go to park to drive, we may see a fluctuation in the pressure control solenoid as we make that transition. But what we're actually going to do is make a transition from park into reverse. Now, if you remember, I was telling you before, pressure control solenoid C is used to put the direct clutches on. The direct clutches are on for reverse, and it's on for fourth and fifth. So these solenoids, if we've got 1 amp on the solenoid, we got minimum pressure. So we're going to go to reverse, which means we're going to need to have full pressure to put the direct clutches on. So we're going to get to see pressure control solenoid C go to 0 amps to put the direct clutches on, and that's going to be channel 3 with the green wire. Now, one little extra tidbit. Sometimes, even though we might see the amp drop to 0, we still may have a delayed engagement in the reverse. Rarely happens, but inside the valve body there's 2 check balls, and one of them's in what we call a bathtub, a shuttle ball. That shuttle ball has got to fully seat for the direct clutches to apply. So sometimes if we have a problem with the ball, even though we see the amp drop on pressure control solenoid C, we still may have a delayed engagement in the reverse. But at least we know the computer's command. So what we're going to do is take a look at the
screen.
At the screen.
And Wayne, we have a question first on the amp clamps. They want to know, and I'll answer this, what we have it set up on. The setting is 1 MV equals 10 milliamps. So that conversion also goes into 100 millivolts equals 1 amp. It's the first click on these UEI clamps. We're using the E-scope, and Wayne will be explaining the colors. Once again, you're going to need to point out on what we have.
So now what we see here is we're at a 1/2 amp on pressure control solenoid B. Now the B is at a 1/2 amp, and all we're going to do is go from park to reverse to neutral to drive, and it'll always stay at a 1/2 amp throughout those ranges. So we're never going to see pressure control solenoid B change. You will see it if you went out on a road test, but we're not going to be doing that.
And that's the red line we're looking at.
That's the red line. Now up here on 1 amp, we're seeing pressure control solenoid A, which is the yellow wire, and we have pressure control solenoid C, which is the green wire. And what we're going to see happen when we go to reverse, we're going to see this green wire go to 0 amp, which is what's going to put the direct clutches on and seat that bathtub check valve. So why don't we go and put it in reverse?
Alex, please put it in reverse.
Now look at that. It went right down to 0 amps, full pressure, and it should have engaged in the reverse smoothly and immediately.
And let's look at that one more time. Park. You see that green line went up? Reverse. And we went down.
Now,
Okay.
Now, if there was a delay with the voltage, with the amperage dropping down, then I would look at the transmission range sensor, because if the computer didn't recognize the reverse engagement, it wouldn't change the pressure control solenoid C. Now, we're going to put it back into park. The pressure control solenoid C, as you can see, is still at 1 amp. Pressure control solenoid A went down to a 1/2 amp, because now we have both A and B are at a 1/2 amp. Go ahead, put it back into park.
Now we're both up to 1 amp.
Right.
And still at a 1/2 amp.
Right. So what you're going to see is now pressure control solenoid A has gone into, when it dropped down to a 1/2 volt, 1/2 amp, when we went into the drive engagement. And remember, both pressure control solenoid A and B are controlling line pressure as well as servo apply release. And when we actually make a shift into second gear, we have to put the overdrive band on. Shift pressure control solenoid B is responsible for that, while pressure control solenoid A will handle the intermediate band for third gear, but we won't be able to see that. But we can see how these amperages will alter. And remember, A and B is checked on the mainline pressure tap. C is on a pressure tap all of its own for reverse and for 4th and 5th. So that's what we have here.
Question that we have, Wayne. Someone says, well, I don't have a lab scope. What is another way that I could view this current?
Well, that brings us to the next step, because the next step is being able to do solenoid fast checks, and we're going to show that with this vehicle. But the idea of how we're going to show checking for voltage, checking for ohm, checking for amps can be employed with a whole variety of different vehicles. We just wanted to show you a little bit about pressure control solenoid A, pressure control solenoid B, and pressure control solenoid C. So now we're going to go and show how to do some of these other checks.
Hey, Wayne, wait 1 minute. Before we do that test, how about some of these portable amp clamps at a little more than an amp that you could save? So depending on, always make sure you got a good battery, zero it, and you should be okay. Now we can move on, Wayne, to the next thing. If they don't have an amp clamp, we're going to show them the solenoid fast check. Okay. What are we doing now?
Okay. This is the connector, obviously, that has all the transmission wires going to it. This is where we were amp clamped to pressure control solenoid A, B, and C. What we can do real quick is fuse 38 in the fuse box over on the left side of the engine compartment is what supplies the power down to the solenoid block. It's one power supply, and that power will go down to the solenoid block and then provide power to every single one of the solenoids. And we're talking about pressure control solenoid A, B, C, shift solenoids A, B, C, and D, as well as the lockup solenoid, the TCC solenoid. Now with it unplugged and the key on, I should see battery voltage at every one of those terminals if that fuse is okay and the circuit from the ignition to the fuse and from the fuse down to the solenoid block, we should see battery voltage returning here up to the computer where the computer can control those solenoids on the ground side. So we're going to turn the ignition on, and the first one we're going to check is pressure control solenoid A. We should have battery voltage.
And look at that, we do 12 volts, 870 millivolts, battery voltage.
Now B, pressure control solenoid B.
Same thing, battery voltage.
Pressure control solenoid C.
Same thing, battery voltage once again.
Now at the top here is the lockup solenoid.
Same voltage, battery voltage.
Shift solenoid D.
12 volts, 870 millivolts.
C.
Same thing, battery voltage again.
B.
Once again the same.
And A.
Beautiful. Now we know we don't have an open circuit.
Right.
But let's open that circuit, right?
Well, we could open that circuit if you wanted to perhaps pull the fuse, and then we could even do a resistance check if we wanted to.
So with the 15 amp fuse pulled out,
Obviously, we have nothing.
we're going to see that the fuse is out on the battery. There's a little blue thing. I'm going to come back to Wayne, and right on the meter.
We have absolutely no voltage here. But now what we could do is we actually could put the negative lead of the meter in the fuse area and actually do resistance checks of the solenoid if we wanted to do that. And that would be if you could put the ground wire
In there, let me get a pin.
I'm going to set this to ohms, and it'll be the leg on the right side.
You got it. Leg on the right.
Okay, so now I'm going to be checking pressure control solenoid A, and I should have around 6 ohms. And look at that, I have 6.2. I'm going to do the same thing with pressure control solenoid B. And I have 6.1. Pressure control solenoid C. I have 6.2. Now I'm going to do the lockup solenoid, and the lockup solenoid is around 10 ohms. And I have 12.5.
So the higher the resistance, the lower the amperage.
That's correct. Now, all the other shift solenoids are approximately 25 ohms. So we're going to see here, we have 29 ohms.
And temperature always changes
Yes,
resistance.
temperature always changes, and obviously we have it pretty hot, so we're a little bit on the high side, but within range. So now we know, right now, we know our pressure control solenoids are measuring 6 ohms. We know that the lockup solenoid is measuring 12 ohms, and we know that our shift solenoids are measuring almost 30 ohms. Now we already know what voltage we have. We now know the kind of amps we should see. We'll be able to see about 2 amps on the pressure control solenoids. We should see about 1 amp, a little over 1 amp on the lockup solenoid, and we should see about a half of an amp on all the shift solenoids. So now how we're going to do that is we want to be able to put the fuse back in.
Yep. So we're going to use Ohm's law. This is basically what you're doing. People don't like Ohm's law, but we showed them voltage, resistance, the amperage has to be in spec. I'm on the negative side of my battery. Wayne is in the 10 amp jack in his fuse. We know we don't have anything with super low resistance that's going to cause a problem. And now we're going to check the current flow going to each solenoid.
And we'll start off with pressure control solenoid A. And look at that, we're supposed to have
2 amps, 100 and something milliamps. Very good.
Pressure control solenoid B.
2 amps, 130 or 25 milliamps.
And C.
C, about the same thing, 2 amps, 100 and something, going down, milliamps.
Right, now we're going to do the lockup solenoid, which should be about 1.2 amps in that area. And we have 1.0 amps.
But you know, Wayne, the problem here that maybe people are thinking out there, this is not something that's constant amperage. These are duty cycle.
Right, they're duty cycle, and the duty cycle will determine the amperage of the solenoid when you're connected to it while it's operating.
Right, because any PCM or TCM that is going to keep something on that long, more than 6 milliseconds, okay, at over an amp, 1.2 amps, they'll burn the driver out.
Right.
So you got to always make sure that we don't have that type of issue. Again, these are duty
And what
cycle.
we're actually doing is an actual load test on the entire circuit ourselves, making sure that between ohms and volts we're having the proper current draw. And in this way we could actually find if there is a problem with the way the solenoid, the harness connector is plugged into the pass-through connector on the solenoid block, which is, as we saw earlier, the air conditioning drips down on that and can give us some issue.
And you know the nice thing I like about this, Wayne? You know, we're doing this on camera, but guess what? People that are doing this in their shop, it ain't even going to take them this long.
No.
Once you have the right information and you don't have to worry about being on camera or anything, this is a lot easier to do, isn't it?
Right, everything that I'm doing can actually take a matter of minutes. I can do this fast solenoid check so quickly. I'll know that I've got my power there, I know that I have my ohms are there, and I know that I have my current draw is there, and I can do it in a matter of minutes. And again, this type of solenoid fast check, if you really scrutinize different wiring diagrams, you can figure out how to do this on many vehicles. Like Dodge vehicles has a relay that supplies power down to the solenoid block on these 41 TE transmissions. You jump the relay, and so that you have that power going down there, and then on the ground side by the TCM, you do exactly what I'm doing here.
And you know, Wayne, I want to give you guys a plug, ATSG. This book here that maybe you should show them has all the information that we've been talking about here. And you can get that right off the ATSG website.
Yeah, it has the connector pinouts, the wiring diagrams, it has the solenoid
current readings,
resistance. Right.
resistance.
Right, it has all of that here. Thanks, G.
You're welcome.
I got one more amp check to make. I want to check my shift solenoid amps, and these are supposed to be about a half an amp.
You're in.
Okay, so now what I wanted to do is check shift solenoid amperage, and we're supposed to see about a half an amp.
And look at that, 447 milliamps.
And the same thing, this is shift solenoid D, and then we're going to go to C,
443,
and then we're going to go to B,
461, 460,
and A.
and 449
So
milliamps.
in a matter of minutes, we checked all the amperages, we got all the volts, we got all the ohms, we know that we got a good circuit here.
And it's pretty simple to do.
Right. The next check that we want to do, that's good to know, is that all the speed sensors, the turbine shaft speed sensor, the input shaft speed sensor, and the output shaft speed sensor, they all share the same ground with the heated O2 sensors. And in order for us to be able to check the ground circuit this way, we have to plug this back in. We actually back probe this under a load, we should be under 100 millivolts. So that's what we're going to do next, G.
Right, and you know, before we do plug that connector back in, we need to turn the key off.
That's right.
So Alex, turn the key off. Then Wayne's going to plug this in, and to do a voltage drop, the circuit has to be loaded. What do we mean by that? That means you're going to have to start the vehicle up when we have this back probe. So you're going to see, Wayne is going to back probe this. We're going to go on millivolts. We need to take our meter leads first and switch them into voltage. I'll get you the connector. Switch your leads first. Here's your back probe pin. I'll take, yeah, you don't need, you can plug that right in the end of the wire. is take the end off. So we're going to take the end off. We're going to put our back probe pin on. And again, we're going to back probe this first before we start it up. And we need it running, or the reading we get on millivolts DC, Wayne will change his scale once he gets us in there to millivolts DC. And then we will see what reading we have. This back probed, the engine is off. You can see we have some millivolts. We're looking for under 100. Take careful notice when Alex starts it up. Watch the reading. Go ahead, Alex. Look at that. We went 1,300 millivolts, and now we're down to about 30. What that was doing is pulling on the oxygen sensor, speed sensors, and other sensors on that circuit. Okay? So we're at 37 millivolts.
Well below 100 millivolts.
Well below 100, and we have a good setup here. Okay. All right, so now we got that check out of the way. And how long did this take us, the whole procedure?
This took us no more than just a few minutes, but we, being in front of the camera, we took a little bit more time explaining it. But if you knew how to do this, you can do this check within 5 minutes or less.
Yeah. You become an expert in minutes.
Yeah, once you do something on a vehicle as easy as this to learn from, and you grasp the concept, you could look at wiring diagrams and become very imaginative on being able to do the same kind of checks, just knowing what kind of system you have, how the power is going down to the solenoid. Obviously, this will be working on solenoids that are operated on the ground side with a power supply. GM has a lot of that type. Ford does. Chrysler does. So there's a lot of vehicles on the road that you can employ this fast, simple solenoid check in your shop.
We want to speak about reflashes. We talked about TSBs earlier on.
Right.
And if there are any reflashes, you should check the vehicle for them, okay, and make sure you do all your updates.
Yeah, and we have a couple of reflashes that related to this particular type of vehicle with a 5-speed transmission, but there's also, this type of vehicle has a 6-speed transmission, and there's quite a number of reflashes for them as well. So it's always good to check and see what's out there. There's TCC shuttle issues, and there's engine hesitations and fluctuations, a variety of different things that can be resolved with a reflash.
That's true. And you know, one thing I want to remind everyone, on Fords, when you reflash them, once they're flashed, you can't go back.
Right.
So you always need to read any bulletins very carefully on what the reflash will do, what it'll fix, and if you're happy with that, you exhibit those particular problems that are in the TSB, then it's a good idea to update it. If not, you may not want to do it. So, you know, reflashing is something that is not hard to do. You need a battery maintainer. You've seen us have one on before, earlier on, during the night. The battery maintainer keeps steady battery voltage as we're doing a reflash. You cannot use a regular battery charger when you're doing this. Make sure you use a battery maintainer, and that'll keep a constant voltage with very low AC ripple going through the system. Wayne, why don't you get back to some of the stuff there on your story, those connectors?
Yeah, see, this is, obviously, this is the connector that we're talking about on these Explorers. And of course, very easy to get to. And in the fuse box, this is fuse 38. And here what we're just doing is a real quick power check on the supply side of the power to the fuse. And we saw that we have 12 volts over here, but then we moved the meter lead over to the other leg to make sure it's coming across the fuse. And of course we pulled the fuse out to make sure that the legs were okay. And obviously this is just to make sure the power is going through. And then of course here, now that we knew that we had power, now you just unplug it. What we did here is took a paper clip and made a spade out of it, tapped down the end and made it nice so that it'll fit in here. And we just checked to make sure each one of those solenoid circuits, pressure control solenoid A, B, and C, shift solenoid A, B, C, and D, lockup solenoid, they all should have 12 volts here. And then you can do a resistance check if you turn everything off. On this right side here is the power going down to the solenoid pack. So we can put a lead here. And then we can do resistance checks. And here we're doing one on a pressure control solenoid, and we had 6 ohms. So we had 12 volts, 6 ohms. We're supposed to have 2 amps. So what we can do now,
So hold it, wait, Ohm's law is coming into play? That stuff that no one likes?
yeah, so now here we moved the positive jack over to the amp, moved it to amps, and I had 1 amp. Now here, this is what's really interesting here, because it goes to show that just doing a resistance check of the solenoid does not necessarily mean you're going to find a problem. We had good power, it appears to be. We had good resistance, but yet when we actually put a load on the circuit, all I can pull was 1 amp, and I was supposed to pull 2. And in this particular case, it was because the water had dripped down, got into the connector, and a couple of the pins were just barely touching. They were almost rusted through or corroded through, that when we actually looked, got it up on the lift, you can see all the rust that came down. And when we unplugged it, all this water came out, and a real close look, you can actually see that the pins came out of the solenoid pack. So they were just barely holding on to begin with. And as a result of that, we couldn't pull that 2 amps.
And that was the piece we just looked at prior on
The
the car.
solenoid.
The solenoids. Now
This
wait,
is the harness that plugs
what
into
was the customer complaining of with this car?
It suddenly went to failsafe. Just for him, out of nowhere, he was on a highway cruise, and like air conditioning on. We're in Miami. I'm in Miami. Okay.
It feels like Miami here.
Yeah, that does. So the air conditioning is definitely used a lot, and it was cruising down the road and just suddenly went to failsafe. It finally.
And explain failsafe. They couldn't do what?
With the shift stuck and forth.
So pretty sluggish when they came on.
Well, here is a close-up of the solenoid pack where you can actually see the pins are missing. And you can see how much corrosion got down in here. So that's, but the point again here is that we're looking at seeing how we could do fast checks at the computer. But this particular example really showed once again that just doing a resistance check of a circuit does not necessarily mean the circuit's good. You got to do a load check on that circuit. This is just getting back to the pressure control solenoid and how it influences the pressure regulator valve. This is in the article as well to further explain where pressure control solenoid A is influencing the PR valve, where pressure control solenoid B is influencing the valve. And again, these 2 pressure control solenoids is what's changing mainline pressure at 1 tap. You have a reverse boost here from the manual valve. Okay, so now pressure control solenoid C has nothing to do with this PR valve. It has all to do with controlling the direct clutch apply. So,
And what we have here, Wayne, on the other side here, we have the Ford IDS, the factory tool. So you may want to focus in on this, the factory tool here, and basically giving us a little bit different, similar information, but a little bit different. The factory is looking at amperage. There's about a 1 amp that we've seen on our amp clamp. We can see our pressure reading. And again, what do you think? What one is 561 milliamps?
okay, this is what I was saying before, right? Pressure control solenoid B is going to remain about a 1/2 amp in park, reverse, neutral, drive, 4, 3, 2, 1 in gear. It'll stay at about a 1/2 amp. This will change as it upshifts through the gears. Pressure control solenoid A and B you'll see them toggle and work together in controlling the upshifts as far as pressure control is concerned. Pressure control solenoid C, you will notice that will change when we go into reverse or when we make a 3/4 shift for the direct clutch.
Somebody asked a question.
Yeah.
The question was, although it seems checking amps is the way to go, should doing a voltage drop show the problem too?
Yeah, it could.
Except that problem was after where you test your voltage drop.
Exactly.
You'd see no
And-
voltage drop. It would be
Right.
perfect.
And remember, amperage is always a form of work. It's telling you something's going on. And we were able to see this thing scroll across. Do that again. You know, you were in Look at the difference here in our readings. You can see going up and down, graphing it, the amperage going up and down on our scale, as well as it affects pressure. Look at the pressure readings.
Right, now these pressures, again, that you're seeing here, and there are other scan tools besides the IDS that will show the same information.
It's up a little bit.
It's calculated based on the amperage reading, and this is the pressure that is supposed to be going to influencing the pressure regulator valve, as well as what's going to be going to the direct clutch. This is going to be handling direct clutch.
So there's some information whether you're using, we realize most of you don't use the factory tool, but we wanted to show you that, as well as you can do programming from here and so on. But, you know, you can do programming also for a J2534 box. So a good way, I think, what your article basically brought out is this amperage check, besides the voltage check, is a good way to test the transmission.
Right, and now what happens here now is if you have this kind of information that the scan tool is displaying, and the actual amp checks here agree with the actual amp checks with an amp clamp, yet a pressure gauge shows that the pressures are down across the board, that could then indicate that you have a problem with that valve that's in the pump, or the PR valve in the valve body is literally stuck. But the point is that when you see the amps here and the amps are looking good, and you can actually amp clamp at the computer and the amps are good, but a pressure gauge shows pressure is low, chances are you might not have a solenoid pack problem, you might have a pump volume control problem.
Somebody asked, what about checking these on the bench? And I typed in an answer because you were talking. Basically, I said on the bench you would have to power up these solenoids and measure amps at the same time, but only computer control with it installed would show the various values operationally.
Correct, yeah. Especially since their duty cycle, that's going to make a difference, by the way. If you don't want to heat them up, just checking them on a bench, we showed you it's a quick check to load them up with training fluid is a good idea.
Yeah, and if I remember correctly, terminal 3, this is the connector actually plugging into the solenoid. Terminal 3 is the power supply going in for all these solenoids. So if you wanted to check the pack on the bench, you could put a 12-volt supply here. And then with your amp meter, you know, your negative lead to ground and your positive lead, you can actually touch each one of these pins and see what your amperages are on each one of the solenoids right here at the solenoid pack. But then that would just verify that your solenoid pack is right. But you still have the whole wiring to check now once you put the vehicle, the solenoid pack in the vehicle. And what I wanted to show here is this is where the main line tap is for pressure controlled solenoid A and B, where you can watch what line pressure is and compare that with these amperages and to see if line pressure is going up and down. Once again, as amps go down, line pressure goes up. As amps go up, line pressure comes down. So you can make that comparison here. Pressure control solenoid C is on the other side of the transmission case. And that you can read in reverse, and you can read when you're in fourth and fifth. With some scan tools, to have bidirectional control of the solenoid, you can actually do some checks that way. But I've seen where if there is any kind of issues, bidirectional control is not allowed. It won't allow it.
It won't do it, right? You'll be locked out.
Right, you'll be locked out.
And here's one of the things Wayne was just talking about. I am in, and I'll just move this side of you, Wayne, you can get on that side. It's a little easier for me to do that. Where I'm in here and I could actually activate the solenoids and see what the amperage here, we got 561 milliamps. So exactly what Wayne was talking about with the pin a minute ago, putting the main power in and checking all your solenoids, it's easily done. And again, this Power Probe hook, or the hook by Power Probe, I should say, allows you to do all of that stuff all at once. On aging in transmission, and I think you hit that really well before. We gave the example today of an oxygen sensor code, yesterday of an airbag code, of where you're not going to be able to diagnose and fix the transmission correctly.
Right.
You need to address everything.
Right.
This is why drivability meets transability, because we need to kind of work it together.
That's right. And the thing that I wanted to bring up, as I'm sure most of you probably already know, but is worth repeating, is that the mass airflow sensor on these Fords really have a tremendous influence on line pressure control. So you really want to make sure your mass airflow sensors are good. Obviously, the TPS is good, or any engine load related devices for sure.
So like checking barrel, making sure barrel is right.
Anything related to load, absolutely. Temperature sensors are another one that should never be ignored. Particularly transmission fluid temp is going to tailor line pressure control, converter clutch control, and things of that nature. So you can't ignore a lot of these PIDs. They all absolutely work together.
And let's not forget the basics. You know, the transmission oil temperature is basically affected by what thermostat they put in there.
Yeah,
Is that thermostat properly calibrated? I mean, I've seen problems where transmissions won't, you know, shift as designed because the thermostat they had in there wasn't right.
That's right.
Time to temperature, just like Bernie has on his scan tool, is obviously important. It's not just reaching a temperature, it's the amount of time that
it takes to reach that.
We got some questions.
Yeah, actually, one's a comment. Having the wrong oil could affect pressure in the system, like give it foaming and so forth, and give the wrong gauge reading. That could cause line pressure problems and give a line pressure A solenoid code. Is that correct?
Any foaming is no good. I don't care if it's a wrong fluid, low fluid, you have foaming, you're going to have pump cavitations, and the PR valve is going to be jerky. And obviously the reason why the needle's going like this is because everything else is erratic. You're going to have a variety of different codes, so absolutely.
Yeah, the other one was a question. How does solenoid C influence direct clutch pressure if it does not use the PR valve?
Oh, that's very good question, but I didn't want to get overly involved. It's the way the oil is routed to the solenoid. Remember, all three pressure control solenoids are receiving pump pressure, unregulated pressure from the pump through the pump flow control valve. So they're getting unregulated pressure right from the pump. This is what's very unusual about these particular pressure control solenoids. Most all other solenoids are actually having controlled feed, line pressure control feed, usually 60 pounds, 80 pounds, maybe 90 pounds in some instances, and nothing higher. Whereas these three solenoids are all being fed pump pressure right off the pump, unregulated pressure, which then gets regulated to their respective circuits. There are some solenoids that actually control pressure directly to a clutch. Some of it is actually regulated through another valve. Once it leaves the solenoid, it gets regulated by another valve to put that clutch on. But what we're looking for is enough flow of oil going through that solenoid to be able to control that clutch. I wanted to bring up this internal overdrive gear set. See, sometimes that can also cause harsh shift complaints because the ratio for overdrive affects second gear and fifth gear, because the overdrive band is used for second gear and fifth gear. So you have a ratio change in second and fifth through this overdrive gear set. And if that ratio is not appropriate for the vehicle, the computer is looking at the ratio. You're really not in second gear long enough for it to totally understand that there might be a slipping problem. And so it's trying to adapt so it can affect the shifts. And sometimes if you can get it up into fifth gear and drive it long enough, you could get P0735. You could get P0732. You start getting P0732, P0735, yet some of the amp checks that you might make right at the solenoid itself, everything seems to be fine there. Of course, we're talking amp checks that you do by unplugging the connector and making sure each one of those pressure control solenoids have the right amp. Now the computer means it's controlling that solenoid wrong. Why is that? And if you have P0732, P0735, it could mean that either there is something wrong with the overdrive band, which affects that, or was this unit just recently replaced? Did someone just recently rebuild it? Did you not have that problem before? Now after replacing the transmission, rebuilding the transmission, now all of a sudden you have this problem. Now, we do know that these intermediate and overdrive servos, they have issues wearing out the bore where the pistons go in and out. But if you just finished overhauling the unit, that should have been observed and checked, and if that was an issue, taken care of. So the idea is, the way you can notice an overdrive gear set is simply, was it changed? Did anybody touch it before? And so you don't want to ignore that possibility if some part shifts.
So always play detective and look or ask the
And ask
customer.
questions, that's
So
right.
Powertrain Pro. And Wayne, why don't you just tell them once again, you know, Powertrain Pro, what it's about. You're doing a webcast on the 20th of the month, you know, at 8 p.m.
Powertrain Pro is just a name indicating that it'll be a section in Motor Age magazine that covers automatic transmission related articles. And most of the articles that I put in, I work at shops when I don't travel, and I deal with a lot of great guys on the technical hotline. I've got great guys on the technical hotline, and we harness a lot of real information that happens in the shop, and we try to get that out there through those articles in Motor Age in a section right about the middle of the magazine called Powertrain Pro. Part of the other things that Powertrain Pro will do is offer up various webinars as well. And on June 30th, we're going to have our first Powertrain Pro.
Excuse me, not 20th?
20th. Did I say 30th? I'm sorry. Thank you. June 20th, the first Powertrain Pro webinar. It will be much more of a controlled webinar in the sense that I'll be doing a PowerPoint, and I'm going to be explaining the pros and cons of CVT transmissions, rebuilding them. It'll be sponsored by TransStar. So that's going to happen on the 20th. But also the June issue, twice a year, the Motor Age magazine will come out with a Powertrain Pro edition, polybagged with the magazine. So there'll be a 50-page Powertrain Pro magazine coming out in June with the Motor Age magazine.
And I want to remind people, you know, right now the Powertrain Pro is incorporated in the Motor Age magazine, and these articles that we were referring to, you just wrote them in the past few months.
Yeah.
From the beginning of the year, if I'm not
From the beginning of the
mistaken.
year, and I've been doing weekly newsletters that are technically oriented.
And where could they find those?
They can, you subscribe to them. You go to Motor Age website, and you go to Powertrain Pro, and on the right side it says you can subscribe to those weekly newsletters, which are articles, technical articles. They're not advertisements, they're
And that's
articles.
That's searchautoparts.com
But
or
then-
Motor Age.
Right, then go to Motor Age and go to Powertrain Pro.
ATSG has technical support. Again, if you didn't catch our webcast yesterday or a round table, they have manuals. Go to their website, bulletins, tech hotline, seminars now at Motor Age, and webinars that they'll be doing in the future. And again, that's on the 20th of the month. And here we got to give ourselves a plug at TST. TST, we do a whole bunch of these things for you guys out there to keep you informed. Each one of these are a little different with a little bit of different information. We are so grateful for Wayne coming up from Florida to work with us. I really want to thank you. You know, besides being a personal friend, professionally, I'd like to thank you for coming up and sharing your information, not only with us, but everyone out there. We work better together, and you know, it always helps when you come out. We'll have Wayne out again. And if you're interested in some training, my company, ATTS, that pays the bills, we also like that. So from New York, we thank you, Wayne.
Thank you very
Mr.
much.
Transmission Man. This is G. Truglia. Have a great one. Thank you.